Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi. Okay, so we continue our discussion. During our first part of discussion on heat equation, we already find the solution of this one, of T. Okay, the solution is T equals to AE negative K beta T. Okay, so now we continue to find the solution of X, where the equation is 1 over X d square X dx square equals to negative K. Alright, so we continue here. Right, so the solution that we want to find is U equals to X dot T. Okay, the product solution of X and T, and T already found, but now we want to find what is our X. Okay, recall the equation just now. We have 1 over X d square X dx square equals to negative K. And then what we need to do here is, we know that we have second order linear differential equation here, because this one is second order, because the highest derivative in this equation is 2, so we have second order. So we cannot simply apply the separable equation as what we did on the first order to find the T solution. Okay, the T solution. So now we need to recall the chapter 2, which is the homogeneous equation, which is we want to find the solution of homogeneous equation. So in short, what I can say is we want to find the homogeneous solution. So how to get the homogeneous solution? So what you need to do is, we need to find out the standard equation of second order, which is ay double prime plus by prime plus cy equals to 0 here. Okay, this is our standard equation, and then in order to get the solution, first we need to transform this equation in the form of characteristic equation, which is am square plus bm plus c equals to 0. Okay, so this is the characteristic equation, or sometimes we call this as auxiliary equation. So now, first, before we get the characteristic equation, the first thing is we need to rearrange this equation until we get the standard equation. So I try to multiply or bring this x to the right hand side so that I have this one. Okay, so this is just the algebraic manipulation in order to get the specific equation of the standard equation here, standard form of second order. So I have d square x dx square plus kx equals to 0. So we call this as the homogeneous second order linear differential equation. After this, actually, we can simply transform this equation in the form of characteristic equation, but we cannot do that. Okay, we cannot do that. In order to get the solution of x, okay, in order to get the solution of x, okay, in order to get the solution of x, what we need to do is we need to consider the boundary conditions. Okay, so what are the boundary conditions? The first thing is you need to consider the first boundary condition lah. Okay, the first boundary condition is the temperature at x, the position of x equals to 0, the first n, and the second n when x equals to L. Bukan n kan, this one n. Okay, the end point of your rod. Okay, so the temperature when x0 equals to 0, okay, and the temperature when x equals to L also goes 0. Okay, since now we are talking about x, okay, x, capital X, therefore I just want to consider the x dimension. The x dimension here, the condition here, you have u x and t tau, x and t. We don't want to talk about, you don't want to talk about t. Okay, you don't want to talk about t. We just want to take into consideration the dimension of x only, so that we can rewrite our boundary condition here, okay, as x when small x equals to 0 and x when your small x equals to L, both conditions equals to 0. So that I can conclude that the equation of the equation that we want to find the solution here, okay, d square x dx square plus kx equals to 0, can be rewritten as this one, the same thing, with the condition here, boundary condition x, x0 0, xl 0. Alright, so the solution that we want to find, of course lah, x kan. So if you have d square y dx square, at the end of your calculation, we want to find the solution of y as a function of x. So the same thing here. You have the capital X, d square x dx square. The capital X is your solution. It is a function of small x. And the solution that we interested here is the non-zero solution. Okay, so this one. You must find the non-zero solution of x. So that when we look at into our equation here, our equation, what we need to consider here is what is the value of k which makes, okay, the equation or the solution of x non-zero. Okay, we call this equation here as the eigenvalue problem, and this k we call it as eigenvalue. Okay, what is the value of k, or what is the eigenvalue that can make the non-zero solution? Okay, what is the value of k in such a way that you get the solution of x is not equals to 0? So that is the question. So now, in order to consider the value of k, or in order to find the value of k, we have three choices of value of k. Okay, first one is when your k equals to negative r square, where r equals greater than 0. So which means that when your k is negative lah. So negative, positive, so negative. When your k is negative, the second one is when your k equals to 0, and next is when your k equals to positive r square, where r is greater than 0. So we start with the discussion on when your k equals to negative r square. And then when I choose k equals to negative r square, I substitute into the question or the equation or my q here. So I have x double prime minus r square x equals to 0. And then I transform this equation in the form of characteristic equation. So at this part, then only we transform in the form of characteristic equation. So I have m square minus r square equals to 0. M square equals to r square, so that I can conclude that m equals to plus minus r, which means that you have the first one is r, okay, positive r, and the second one is negative r. Okay, so this one is negative r. So negative, okay, negative r. So two different roots. Okay, so I can say that this one is actually r lah. Okay, R1 ke R2 ke, tak kisahlah kot the value dia. But look, okay, so I can say that I just have two different roots where the roots are positive r and negative r. So this is my solution, CERX and negative CE negative RX. Alright, so that this is, I can conclude that this is my general solution. So when I have the general solution, go back to our boundary condition. The first boundary condition is x0 equals to 0. So x0 here equals to 0. Then I substitute CE R0 plus DE negative R0. So you have negative sign here. So C plus D equals to 0. So CE kosong, DE kosong. So C plus D equals to 0. So that I can conclude that C equals to negative D. So I equate this one as my equation 1. So the second condition is when x equals to 0, when x, the small x equals to L. So small x equal to L equals to 0 here. So I substitute. So I have CERL plus DE negative RL, where C just now is negative D. So I try to factorize the D. So I have this one. Note that this left hand side of our equation must equals to our right hand side of our equation. And we notice that we have exponent here. The exponent cannot be 0. Kenapa? Why? Because there is no value of no value that can make exponent go 0. So this one cannot be 0. So siapa yang akan jadi kosong? What are the term that go 0 to make this equation equals to 0? So that is D. So D must equals to 0, so that this equation, the left hand side, will equal to your right hand side of your equation. So that I can conclude that D equals to 0. When D equals to 0, I substitute back into my equation 1 just now. So I have C also goes to 0. C0, D0, and then I substitute back into my general solution, or I just write it here. So I have not R1, R2. This one is negative, sorry. Okay, so I can conclude that C0, D0, so X equals to 0. I don't want the solution of X equals to 0. Kita tak nak ni. We want the solution when X is non-zero. So that we can conclude that the pemilihan, okay, K equals to negative R square is incorrect, where this K is not the eigenvalue to the problem. So this is not the solution that we want to find. So no, don't want this one. Okay, so we proceed to when K equals to 0. Just now is K is negative, so now K equals to 0. Substitute into X double prime plus KX equals to 0. When K equals to 0, so we have 0 here. So X double prime equals to 0. Reduce or transform this equation in the form of characteristic equation. We have M square equals to 0. Oh, we have M equals to plus minus 0, which is 2 equal roots. When we have 2 equal roots, try to recall, we have the solution of Y previously, chapter 2, Y equals to AEMX plus BX So here we have capital X equals to AEM1X or AEX plus BXEMX. So your M just now is 0. So we can conclude that we have A plus BX. Substitute our boundary condition X0, 0. So we have left hand side equals to 0. Your right hand side is A plus B0. So we can conclude that A equals to 0. The second condition is when your XL, X equals to 0, when your small x equals to 0. So your left hand side is 0. Your right hand side is A just now is 0 plus BL. BL equals to 0. Therefore, we can conclude that B also 0. A0, B0. So what is the solution? The solution is just now apa tadi? The solution is X also goes to 0. Okay, so this is our solution. Okay, this is our general solution. Substitute A0, B0 so that we have X equals to 0 lah. So this is our conclusion. Alright, so therefore we can conclude that K is not the eigenvalue because K will make the K equals to 0 will make the equation the solution of X equals to 0. So this is not what we want. This is not what we are looking for the solution. This is not correct, and the first one is also not correct. And we hope that the next video of K we will get the solution of non-zero. Okay, Bismillahirrahmanirrahim. Ada pergi ni. Right. Okay, so next we continue. So this one is not the correct value of K. So now we continue our discussion when K equals to positive R square. So this time we have K equals to positive R square. Substitute into our question just now or equation just now here, equation. And then your K is R square so that we have this one. Okay, and then transform into the form of characteristic equation. We have M square plus R square equals to 0. M square equals to negative R square. Therefore, M equals to plus minus Ri. Where this one we have two complex roots. And when we have two complex roots, please recall that we have the roots of alpha plus minus beta I. Comparing to this term, we note that alpha is 0 and beta equals to R. So exponent alpha x plus dalam kurungan inner bracket A cos beta x plus B sin beta x, so that this is our solution. X equals to A cos Rx, where your M is R, okay, plus B sin Rx. So this is our general solution. And then substitute the condition. The first condition is X equals to 0. So that I substitute here. When small x equals to 0, when small x equals to 0, tak nampak. When small x equals to 0, I have A cos Rx, okay, plus B sin 0. B sin Rx is B sin 0 is 0. Okay, 0. So I have A cos Rx. A cos Rx is A cos 0, which is A cos 0. Cos 0 is 1 equals to 0. So that cos 0, cos 0. So I have A equals to 0. Substitute here. A cos 0 is A plus B sin 0 is 0. So this one is 0. So I have A lah. A equals to, left hand side equals to 0. So A equals to 0. The second condition is XL equals to 0. And then I substitute into this equation, the general solution. A just now is 0. Habis. So tinggal B sin Rx. B sin Rx is when your x, small x is L. So I have B sin RL equals to 0. Note that previously our K is, our X solution is 0 when we have K positive and negative and K equals to 0. So now we don't want to get the non-zero solution. We just interested in we just interested in non-zero solution because previously we have the zero solution of X. So what we need to do is we need to do some modification to our solution here. So B sin RL, okay, B sin RL equals to 0. Okay, B sin RL equals to 0. What is the value of B that we want to find here? So that this equation, your left hand side of the equation equals 0. Okay. So siapa yang akan jadi kosong? B tak boleh kosong. If B equals to 0, we will get X equals to 0. So we don't want that thing happen because we want the non-zero solution. So that siapa yang akan kosong? Sin RL will go 0. What is the value of sin that will make the solution 0? You will always have sin n pi equals 0. Sin n pi memang kosong. So we just compare sin RL equals 0. How you get 0? So RL equals to your n pi. So that when you substitute here, sin n pi equals to 0. So that is why we compare n pi and RL. We want to find what is the correct value of R, so that R equals to n pi over L. And then go back to our choice of X. Sorry, bukan X, K. K is R square tau. K equals to R square. What is R just now? R is n pi over L. K is R square. So, K is n square pi square over L. Therefore, this is the correct value of K. This is the correct eigenvalue that will make our solution X is non-zero. Okay, so that I have the solution of X is this one, A cos Rx plus B sin Rx. So I substitute A just now is 0, habis, plus B sin Rx, which is B sin R is n pi over L and times your X. So this is your solution of X. Just now 0, 0, the solution of X, but this time you have X equals to B sin n pi over X. So that we can proceed to the solution. Okay, so now since we have the solution of X, so we go back to our discussion. The solution is U equals to X dot T. So your T is here, okay, and your X is what we have found just now. But note that since your solution consists of N, ada N tau dekat sini. N means that you have infinitely many solution. Bukan infinitely, you have many solution lah. Okay, kita tak tahu. So we say that you have infinitely many solution. So that what we do is we need to do, or you need to put the summation sign. Okay, summation sign where N from 1 to infinity. Okay, infinity. Okay, B dot A, this solution, you need to put the summation so that we have many solution. So you just copy back what we have previously. Okay, and note that A dot B is not simply a C. Bukan, dia bukan A dot B equals to C, bukan constant. Since you are dealing with a series of solution now, so you have Bn. Okay, or E is E, negative K. K just now is R square, where R square is this one. So substitute K here. And then beta T is just beta T. And then plug in your sin n pi over L. Di mana your B, where your B is given by this one. Macam Fourier series kan. So this is a Fourier series lah. So Bn is this one. So you substitute this one. So you need to integrate outside. Okay, and then plug in into the solution here. Okay. So integrate your Bn. So you get the Bn equals to 2 over L. Integrate from 0 to L fx sin n pi x over L. Alright. And then what is your fx? What is your fx? Fx is the condition. The condition that you find or you obtain from the boundary condition. Mana boundary condition tadi? Okay. Recall the boundary condition. Wah, nak kena recall pula kan. Apa ni media nak kena recall? Sama lah tu. So you need to relate to each other lah. Okay. So this is your second boundary condition. So fx kan. So fx here kan. So you need to substitute here. Your fx. Okay. So that is your Bn. And after you get your Bn, macam kita calculate or compute for Fourier series and then substitute into your solution of U. So U equals to x dot t here is not simply macam kita buat during our first discussion previously. Still we need to find x dot t, but this x consists of second order. So this is how we solve for the x. Okay, so it involves Fourier series. So I really hope that this video will help you, and please find the examples on the textbook and please do a lot of exercises on this matter, okay, to make sure that you are familiar with the heat equation, one-dimensional heat equation. Solve the equation by using the SVM. Okay, so good luck everyone. Assalamualaikum.